The emergence of the new space era has significantly transformed access to space through the introduction of CubeSats, small satellites with multiple advantages that have facilitated more frequent project implementation by universities and research centers. But as these platforms become smaller and more accessible, one challenge remains essential: controlling the satellite's movement in space. However, movement alone is not enough. The fly of a bird, balance becomes from continuous control and adjustment, and as in dance, turns are the most sophisticated control tool. Control is what turns motion into mission success. Nowadays, reaction wheel systems are the most recommended when the main objective is the precision and the performance of the attitude control. The spinning objects allow a space object to be in the right direction without the use of a propellant, increasing satellite's lifetime without the human intervention. This project focused on developing an electrical interface board to control this system on a Kitsat CubeSat. From theoretical analysis to prototyping and testing, the project encompasses multiple phases of a typical space mission, with the objective of successful control and demonstration. The process began with communication, first ensuring a stable link with the Kitsat, and then establishing communication between the Kitsat and an external ESP32 microcontroller that served as the processing and control unit. Once the communication layer was working, the next step was to read and send gyroscope data from the CubeSat so that the system could understand its current motion state. From the gyroscope measurements, the control estimated the satellite's angular motion, compared it with the desired stable attitude, and calculate the command values to send to the reaction wheel. These commands are then converted into PWM-compatible signals, allowing transmission of commands in a format that hardware can interpret. Finally, the correct timing and duty cycle of those PWM outputs allow the EIB to activate the reaction wheel motor properly through the ESC motor driver. Motion to control, from data to action. The EIB gives the Kitsat the stability needed to stay on mission.